Hello everybody, my name is Yasuji here. Welcome to my competitive programming tutorial series, where I will be teaching you guys how to solve competitive programming questions as well as methods and phenomenons to use. Today, we will be learning about recursion. What is recursion? Recursion is the concept of running a method over and over again until a solution is found. Think of it as putting a mirror in front of a mirror. However, when you put a mirror in front of a mirror, it infinitely keeps on making a reflection. However, with recursion, there is a finite set of number of times it will be run, and eventually a function will be completed. The best part about recursion is that you really only need one test case, because you take that test case and put it into the function, and that function will keep on running again and again, and modifying it by itself. Because it only needs one test case, it will require little logic. And because you only need to write little logic, you can simply focus more on that small amount of code and write it efficiently in a log n or O of n notation. The issue, however, is that it sometimes will take up more space. It is very difficult to debug. And because recursion is stored inside of system memory and is constantly stacked on top of one another, it will eventually overflow if you have not written your code properly. However, I'm here to help you learn recursion and hopefully prevent stack errors. The question we will be working on today can be found on DMOJ and also on Waterloo's website, the University of Waterloo, by the way. It's a university in Canada, one of the best. They do coding competitions. So the problem is called epidemiology. People who study epidemiology use models to analyze the spread of disease. In this problem, we will use a simple model. When a person has a disease, they infect R number of people, but only the very next day. So let's suppose if I have a disease, all right, and the user is going to specify R, and that's the number of people I will infect. So if I can infect 5 people, I'll infect 5 people the next day. No more is infecting more than once. We must determine the total number when more than P people have had the disease. So there's going to be a value P, and that's going to be sort of like the, we want to see in how many days will it cross. Okay, there are 3 lines of input. Each line contains one positive integer. Okay, the number of people who have the day on day 0, blah, blah, blah. Okay, this is what it's saying. So the first line is going to be P. So as you can see in this test case here, 750 is P, the number of people that we want to see if infected. The second line contains N, the number of people who have the disease on the first day, which is 1. And R will be the rate, 5. So we will get an output of 4, because on day 1 person will be infected on day 0, then 5 people on day 1, on day 2, 25, 3, 125, and once you add this all up, we'll eventually get 781, which is greater than 750. The same can be seen for over here. So let's look at my solution. So I'm just going to paste my solution right here, and we will now go through it. First of all, I ask the user for 3 pieces of input. The number of people infected, or no, the record, so that's P. Then the people infected, the rate of infection. I then create a variable called days, which is equal to 0, because it starts off as day 0. Next, what I do is I check if the infection rate and the number of people infected are both 1. If both of them are 1, we can simply print P. This makes our code more efficient because it doesn't have to run through the entire recursive function. Now, because that's not possible in most scenarios, I will now call upon the function with the value of the days, people infected, the rate of infection, P, and the total people infected, which in this situation is equal to the number of people infected. Then, it's going to check if the total number of people infected is greater than the record. If it is, then just print out days and we've gotten our solution. If not, we need to take days and increment 1, take the number of people and times that by the infection rate, and then add that people infected to the total number of people infected. Then we will run this function again over here. And now we've got a recursion that runs constantly, and eventually a solution will be found. Waterloo, as well as most other competitive programming makers, they do not put in bad inputs that will cause problems. So we can be certain that there won't be any functions that are, or any inputs or test cases that are incorrect. Now, if we were to submit this, boom, perfect. We have a full 15 on 15 right off the bat. Thank you for watching this short video regarding recursion and competitive programming. Thank you. Have a nice day.